digital personal assistants such as Amazon's Alexa and Apple's Siri SEXIST. According to one expert, they struggle to understand quiet and breathy voices of women compared with the deeper voices of men. The software is often developed with the help of male voice examples and so lacks a deeper understanding of female commands. The comment was made by Dilip Rao, the CEO and co-founder of A7 Speech Sciences, a company that uses artificial intelligence to understand speech. Scroll down for video. Mr. Rao explained that the fundamental frequency of a person's voice is what is often perceived as the pitch. This is also called mean F0. The range of tones produced by our vocal tract is a function of the distribution around that. We know the mean F0 for men is around 120 Hz and much higher for women, 200 Hz, he said on his website, as well as the pitch difference between the ears. Females tend to be quieter and have more breathy voices, says Dr. Rajal Tatman, a data scientist at Kaggle, the Google-owned data science firm. She explained to the Register that the learning algorithm in the AI voice recognition devices does not inherently prefer men. It is just that men provide a better signal, she said. There's a slightly less robust acoustic signal for women. It's more easily masked by noise like a fan or traffic in the background, which makes it harder for speech recognition systems. Audio signals are converted into MFCCs, male frequency cepstral coefficients, by the machines. These MFCCs allow computers to process and understand the voices of humans and are commonly used in automated speech recognition models. Dr. Tatman believes that there's nothing about MFCCs in particular that are less good about modeling women's speech than men's. Despite this, the likelihood for a female's voice to get drowned out can make it harder for the machine to understand the commands, as well as the audio makeup of the voices being different between genders. The way the machines are taught could be at fault. In order to develop voice recognition ability in machines, a dataset of people is used to understand what they are saying. Unbalanced datasets can result in bias toward a certain demographic. Deep learning, in particular, is very good at recognizing things that it's seen a lot of, and if you've trained your system on data from 90% men and 10% women, unlikely but possible, especially if you're not accounting for gender in your training data, you'll end up being very good at recognizing male data and very bad at recognizing female data. More worryingly, this also applies to things like race and ethnicity, where there isn't an acoustic reason for one group to be harder to understand. Dr. Tatman said, a lack of diversity in the training phase of the AI has resulted in bias towards white men with a Western accent. Recent studies have found that facial recognition systems are better at identifying males compared to females. The same software is also more adept at recognizing white faces over black faces. A study called Gender Shades has found that facial recognition may not be working for all users, especially those who aren't white males. A researcher from the MIT Media Lab discovered that popular facial recognition services from Microsoft, IBM and Face++ vary in accuracy based on gender and race. The study found that when the person in a photo was a white man, the facial recognition software worked 99% of the time, but when the photo was of a darker-skinned woman, there was a nearly 35% error rate. AI systems rely on artificial neural networks (ANNs), which try to simulate the way the brain works in order to learn. ANNs can be trained to recognize patterns in information, including speech, text data, or visual images, and are the basis for a large number of the developments in AI over recent years. Conventional AI uses input to teach an algorithm about a particular subject by feeding it massive amounts of information. Practical applications include Google's language translation services, Facebook's facial recognition software, and Snapchat's image-altering live filters. The process of inputting this data can be extremely time-consuming and is limited to one type of knowledge. A new breed of ANNs called adversarial neural network spits the wits of two AI bots against each other, which allows them to learn from each other. This approach is designed to speed up the process of learning, as well as refining the output created by AI systems.
Tell me where the freak's at.